Welcome to The Circuit. This week we're highlighting the brilliant minds of biomedical engineers who are creating the technology that's taking medicine to the future. Whether it's bringing movement back to paralyzed limbs or 3D printing organs, here's all the latest biotech buzz. Imagine this: a patient once paralyzed can now walk on their own 2 feet. So how's this possible? A Swiss-based company created a device that wirelessly connects the part of the brain and the spinal cord that controls movements, transforming mere thoughts into remarkable actions.
Not only he could leverage this digital bridge in order to control his paralyzed muscle, but also show a recovery of neurological function he has lost for many years.
NeuroRestore showed how a 40-year-old man paralyzed with a spinal cord injury following a bicycle accident was able to walk again using brain-computer interface or BCI technology. But they're not the only company working on brain technology, of course. Elon Musk's brain implant company Neuralink announced they received FDA clearance to move on to human clinical trials. But their vision is a little different.
In the long term, literally could interface with every aspect of your brain. And in the short term, can interface with any given section of your brain and solve a tremendous number of things.
Picture this: a lab so extraordinary it could be mistaken for a mystical alchemist's den. But instead, it's a cutting-edge 3D bioprinting lab at the University of Minnesota where dreams of on-demand organs come true. Whether it's creating small beating hearts or making 3D tissue models to improve cancer therapies, the facility combines biology and engineering, allowing biomedical engineers, mechanical engineers, scientists, and surgeons all to work together.
What we envision is a huge impact on the lives of patients who are on transplant waiting lists, and will actually help decrease the stress on the donor supply.
In 2018, engineers 3D printed a bionic eye that proved they could 3D print semiconductors on a curved surface and turn light into electricity, powering the device to enhance photoreceptors. Last year, doctors amazed the world by successfully transplanting a 3D printed ear with living cells. Talk about an irresistible breakthrough. But hold on to your stethoscopes, because now the brilliant minds at Stanford University are raising the stakes and aiming straight for the heart. Pediatric heart disease is one of the most common forms of congenital birth defects in the US, and bioengineering professor Mark Schuyler Scott is working on a new approach by building engineered heart tissues in the lab.
So we're working on technologies to be able to manufacture human tissues larger, faster, and at higher resolution.
According to researchers, this method works well for replicating complex tissues like the heart, where 3D form matters for its function. In a collaboration that could make hearts skip a beat in a good way, an engineer and a cardiologist at Purdue University are joining forces to revolutionize the world of echocardiograms and rescue newborn babies facing birth defects.
But with our technology, we can provide the surgeons an understanding of not only what the heart looks like, but also how it functions.
Armed with this scientific snapshot, doctors can uncover how well the heart is working and evaluate its performance, ensuring even the tiniest engineers are off to a stellar start. With a touch of physics, they can also measure, analyze, and make sure these miniature organs are working their rhythmic magic. That's all for this week. Thanks for joining us on The Circuit News. Don't forget to like this video and follow us at Circuit News TV.